Halina mga bata, tayo nang mag-aral sa math, walang maiiwan. Math-sayang math-aral, tayo ng math-tuto upang ika'y umasenso. Maging matyaga, maging matalino, halina't mag-aral na tayo. Maging matyaga, maging matalino, halina't mag-aral na tayo. Halina mag-aral na tayo. Halina, 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 mag-aral na tayo.
Magandang tanghali, Batang MANDunong. Kanina napakinggan natin ang advanced study sa week 5 and 6 o Mathematics 8 CLAID learning modules. Ngayon naman tatako tayo sa advanced lesson sa week 5 o Mathematics 9 CLAID learning modules. To introduce our speaker, she is teacher 2 and now she is 7 years in service at Isaac Lopez Integrated School. She is grade 9 level head and mathematics 9 teacher. Let us all welcome Miss Juno Omega P. Camacho.
Thank you, sir. To our officer in charge, Office of the Schools Division Superintendent, Dr. Romela M. Cruz, Sese. To the officer in charge, Office of the Assistant Schools Division Superintendent, Dr. Aurelio G. Alfonso. Mrs. Emma G. Arubio, Chief of School Governance and Operations Division, Dr. Aline G. Mendoza, Chief of Curriculum and Implementation Division, all education program supervisors, EPS in Mathematics, Mr. Restituto Ira Delas, and public school district supervisors. To our school principal, Mr. Roberto Pire Dobante, viewers, teachers, home learning partners, and to all Batang MANDunong, a pleasant day. And welcome to Project SOAR, series of online academic reviews of mathematics CLAID learning modules. I am Teacher Juno of Isaac Lopez Integrated School, your math buddy for today's lesson in Mathematics 9.
Good day, everyone, and welcome to another series of online academic reviews of Mathematics 9 CLAID learning modules. For today's session, we will be having a review on Week 5 lessons about quadratic inequalities. But before we start, let me share with you the following objectives. First, to illustrate and solve quadratic inequalities. And second, to solve problems involving quadratic inequalities. Let us start our discussion with illustrating quadratic inequalities. A quadratic inequality is an inequality that contains a polynomial of degree 2 and can be written in any of the following forms: ax squared plus bx plus c greater than 0, ax squared plus bx plus c less than 0, ax squared plus bx plus c greater than or equal to 0, and ax squared plus bx plus c less than or equal to 0. The following are examples of quadratic inequalities. S times quantity s minus 9 greater than 0, m squared plus 3m less than negative 4, 3x squared minus 12 greater than or equal to 5x, and x squared less than or equal to 8x minus 12. Now, let us check your understanding about the concept. Determine which of the following are quadratic inequalities. For number 1, we have r squared minus 10r plus 25 greater than 0. Is it a quadratic inequality or not? Yes, it is a quadratic inequality because it has a degree of 2 and the inequality used is greater than. For number 2, we have 2w squared minus 4 minus 7w equals 0. Because of the equal sign, number 2 is a quadratic equation. Therefore, it is not a quadratic inequality. Next, n times the quantity n squared minus 7 less than 0. If we simplify the given, we will be having n cubed minus 7n less than 0. Since the highest exponent is 3, therefore it is not a quadratic inequality. For number 4, we have x times quantity 2x plus 5 greater than or equal to 3. If we simplify the given, we will have 2x squared plus 5x greater than or equal to 3. Since the highest exponent is 2, Therefore, it is a quadratic inequality. For our next topic, we have solving quadratic inequalities ax squared plus bx plus c greater than 0 and ax squared plus bx plus c less than 0. To solve a quadratic inequality, apply the rules in factoring quadratic equation to find its roots. These roots will be used as the points to be plotted on the number line. It will separate the line into 2 or 3 intervals. An interval is part of the solution of the inequality if a number in that interval makes the inequality true. To graph the solution set on the number line, use the hollow circles on the roots or points of the equation when the symbol used in the mathematical statement is less than or greater than. This is to show that the roots are not part of the solution set. For example, let us solve and graph the solution set of the quadratic inequality x squared plus 2x minus 8 greater than 0. First is to rewrite the inequality into quadratic equation. Thus, we have x squared plus 2x minus 8 equals 0. Next, solve for the roots of the quadratic equation. So we have x squared plus 2x minus 8 equals 0. Using factoring, we will have x plus 4 times x minus 2 equals 0. Applying the zero product property, we have x plus 4 equals 0 and x minus 2 equals 0. X equals negative 4 and x equals 2. Therefore, the roots are negative 4 and positive 2. Use these roots to be the points on the number line. The three intervals of the quadratic inequality x squared plus 2x minus 8 greater than 0 are x less than negative 4, negative 4 less than x less than 2, or numbers greater than negative 4 but less than 2, and x is greater than 2, or numbers greater than 2. Test a number from each interval against the inequality. For x less than negative 4, let x equals negative 6. So we have x squared plus 2x minus 8 greater than 0. Substitute the value of x, which is negative 6. We have 14. 14 greater than 0 is true. For negative 4 less than x, x less than 2, let x equals 1, a number between negative 4 and positive 2. So we have x squared plus 2x minus 8 greater than 0. Substitute the value of x, which is positive 1. So the result is negative 5. Is negative 5 greater than 0? That is false. For the last interval, we have x greater than 2. So let us find or use a number greater than 2. Let x, for instance, is equal to 3. So substitute the value of x, which is 3, to our quadratic inequality x squared plus 2x minus 8 greater than 0. So we have 3 squared plus 2 times 3 minus 8 greater than 0. So the result is equal to 7. Is 7 greater than 0? Yes, it is. So it is true. Therefore, the solution set of the quadratic inequality x squared plus 2x minus 8 greater than 0 is x less than negative 4, or x is greater than 2. To graph the solution set of the quadratic inequality on the number line, simply blacken the parts that satisfy the solution set. Always use hollow circles for the critical points on the number line. How about solving quadratic inequalities ax squared plus bx plus c greater than or equal to 0 and ax squared plus bx plus c less than or equal to 0. To graph the solution set on the number line, use the solid dot on the roots or points of the equation when the symbol used in the mathematical statement is less than or equal, or greater than or equal. This is to show that the roots are part of the solution set. For example, let us solve and graph the solution set of the quadratic inequality x squared minus 2x minus 24 greater than or equal to 0. First is to rewrite the inequality into quadratic equation. Thus, we will have x squared minus 2x minus 24 equals 0. Solve for the roots of the quadratic equation using factoring. So we will have x squared minus 2x minus 24 equals 0. The factors are x plus 4 and x minus 6. Applying the zero product property, we will have x plus 4 equals 0 and x minus 6 equals 0. For x plus 4 equals 0, add negative 4 to both sides, so x is equal to negative 4. And for x minus 6 equals 0, add positive 6 to both sides, so the value of x is equal to 6. Therefore, the roots are negative 4 and positive 6. Use these roots to be the points on the number line. The three intervals of the quadratic inequality x squared minus 2x minus 24 greater than or equal to 0 are x less than negative 4, or numbers less than negative 4, negative 4 less than x less than 6, or numbers greater than negative 4 but less than positive 6, and x greater than 6, or numbers greater than 6. Test a number from each interval against the inequality. For x less than negative 4, let x equals negative 5. So we have x squared minus 2x minus 24 greater than or equal to 0. Substituting the value of x, which is negative 5, we will have negative 5 squared minus 2 times negative 5 minus 24 greater than or equal to 0. 25 plus 10 minus 24 is equal to positive 11. So we have 11 greater than or equal to 0. Is 11 greater than or equal to 0? Yes, it is. So it is true. For the next interval, we have negative 4 less than x less than positive 6. So let us use a number between negative 4 and positive 6. Let us use positive 2. Substitute positive 2 in the inequality x squared minus 2x minus 24 greater than or equal to 0. So we have 2 squared minus 2 times 2 minus 24. So 4 minus 4 minus 24 greater than 0. 4 minus 28 greater than or equal to 0. So we have negative 24 greater than or equal to 0, which is false. So since it is false, it means that it is not included in the solution set. For x greater than 6, let us use 7 as it is a number greater than 6. Substituting 7 in the inequality x squared minus 2x minus 24 greater than or equal to 0, we will have 7 squared minus 2 times 7 minus 24 greater than or equal to 0. We have 49 plus 14 minus 24 greater than or equal to 0. 63 minus 24 greater than or equal to 0. 39 greater than or equal to 0. Is 39 greater than or equal to 0? Yes, it is. So it is true. Therefore, the solution set of the quadratic inequality x squared minus 2x minus 24 greater than or equal to 0 is x less than or equal to negative 4 and x is greater than or equal to positive 6. To graph the solution set of the quadratic inequality on the number line, simply block in the parts that satisfy the solution set. Always use a solid dot for the critical points on the number line. Therefore, the graph of the solution set for x squared minus 2x minus 24 greater than or equal to 0 is shown below. Now, let us solve a problem involving a quadratic inequality. Solving problems involving quadratic inequalities are different from solving problems in quadratic equations. In solving problems involving quadratic inequalities, there are words used on the problem to determine the mathematical symbol to be used as inequalities. Let us try to solve a problem that involves quadratic inequalities. An object is launched from ground level directly upward at the rate of 48 meters per second. The equation for the object's height is h of t equals negative 6t squared plus 48t. At what time the object is above a height of 32 meters? To solve the time of the object, let us determine what symbol will be used in the equation. Since the word used on the problem is above, then the symbol is greater than. Thus, h of t equals negative 16t squared plus 48t. We will have negative 16t squared plus 48t greater than 32. Applying the rules in rewriting quadratic inequalities in standard form, we will have negative 16t squared plus 48t greater than 32. It will become negative 16t squared plus 48t minus 32 greater than 0. 16t squared minus 48t plus 32 is less than 0. Reducing it to lowest term by dividing the whole equation by 16, it will become t squared minus 3t plus 2 less than 0. We write first the inequality into quadratic equation, then find the roots of the equation. Using factoring, we will have t squared minus 3t plus 2 less than 0. The factors are x minus 1 and x minus 2. Applying the zero product property, we will have x minus 1 equals 0 and x minus 2 equals 0. Adding positive 1 both sides in x minus 1 equals 0, we will have x equals positive 1. For x minus 2 equals 0, add positive 2 to both sides, so we will have x is equal to positive 2. Therefore, the solution set of the quadratic inequality t squared minus 3t plus 2 less than 0 is positive 1 less than x less than 2. It only means that the time when the object is above 32 meters is between 1 second and 2 seconds. Now, as an exercise, try to answer the following questions. Is negative 2 a solution of x squared minus 3x minus 4 less than 0? As we substitute negative 2 in the given quadratic inequality, it does not satisfy the inequality. Therefore, it is not the solution of x squared minus 3x minus 4 less than 0. Is positive 5 a solution of x squared minus 12x plus 35 less than or equal to 0? Substituting positive 5 in the given inequality, we will have 0 less than or equal to 0, which is true. Therefore, positive 5 is a solution of the given quadratic inequality. Thank you for watching and happy learning!
And that's all for today. I hope that you learned something from me. Thank you for watching and happy learning!